Welcome to a Bottle Rocket and to our inaugural Tech Titans Blockchain Forum event. Thanks to Paul, Bendel, and Shannon and other Tech Titan folks for helping us to organize this. My name is Mark Rasmussen. I'm a partner at the law firm Jones Day. And along with Jon West, one of the co-chairs of the Blockchain Forum that Tech Titans started this year. For those that don't know about Tech Titans, it's the largest technology trade organization in Texas. Its members collaborate, share, and inspire creative thinking that fuels tomorrow's innovations. Through events like today's presentation and other forum events, and the Tech Titans Awards Gala that they hold every year. This one's in August, and much, much more. Tech Titans really helps the North Texas community. Today's presentation is the first of our 3 programs this year. This will be on technology, as you already know. The next one will be September 25th at my firm in Uptown, Jones Day. That'll be on legal issues related to blockchain technology. And then we'll close it out November 14th when we'll talk about business applications of blockchain. Our goal through this 3-part series is to provide you with better understanding of blockchain, how it's applied, some of the risks, some of the legal issues. And at the same time, we want to contribute to the growth of the tech industry here in North Texas. We want to thank Bottle Rocket and recognize Jonathan Campos and those who've worked with Jonathan and thank them for hosting us today. This is a great venue for us. There's a printed program at your seats that provides information on Tech Titan events, so please take a look at that and see if you can attend any other things. For those interested, we do hold blockchain forum meetings third Monday of each month at 8 a.m., so that might deter some of you, but not John. He's the early riser. So if you're interested in joining us to help organize future events and just kind of share thoughts on blockchain technology, you're welcome to join us. It's out near the Richardson Chamber of Commerce. Also, importantly, there are surveys at your seats for you guys to comment on how well these guys do today. We ask you to take a few minutes after the panel discussion to fill those out. Please turn off your mobile devices, and now on to our program. So as I mentioned earlier, this is the first of our 3-part series. It's on blockchain, or as some folks prefer to call it, distributed ledger technology. The terms are very much interchangeable. Blockchain is one type of DLT. DLT is going through its own hype cycle, and it's promising to change the world. Yet the number of issues facing the technology seems overwhelming. Today we've got this great panel up here of experts to discuss, will blockchain's technical issues ever get solved? And to introduce our panel and to moderate the discussion, please welcome Vice President of Technology at Thomson Reuters and one of the co-chairs, as I said, of the Blockchain Forum, Jon West.
Thanks, Mark. Welcome, everyone. It is an honor and a pleasure to be up in front of you here today. And actually, this table right here is open. We've vacated, and we vacated to let people come and sit there. So come and sit there, please. But thanks for coming. It is great to see such a big crowd, and I'm very thankful for a big crowd. And the reason is because we have a special treat, and it's because of these gentlemen right here. Very impeccable resumes. Each one of them stand out as pioneers in the blockchain world. I suspect that their opinions and their perspectives are going to change over the next few years as blockchain, distributed ledger technology evolves, because it's new. But what their opinions and perspectives today are priceless. So it's very fortunate that we have them. And it's also, we have a good, not in terms of just expertise, but a good cross-cutting representation in the industry in a way. We have a new startup, an old startup, and a large corp. So that's a good cross-cutting, well-represented group. So it's worth noting that we're going to be criticizing or talking about distributed ledger technology issues today. So we're going to be on the criticism side. So, but don't interpret that as our lack of confidence or a lack of support for this technology or what it can do, because I think, I know that any one of these people can stand up and have stood up for hours or days to talk about the merits of blockchain and what it can be used for and what it is used for and the potential. So that's a point worth noting. So how this is going to work, I'll introduce the topic, and then we'll let each panelist introduce themselves and give a little bit of a background of their company and what they're doing. A couple of minutes there. And then we'll get into Q&A mode and for the panel. So we'll just go back and forth and discuss some questions. And I suspect we won't get through all of the questions. We will run out of time. But we'll save a little bit of time, too, at the end, just to let each panelist sort of summarize their thoughts, after us discussing this and getting their juices flowing and getting their minds wrapped around some of this stuff again, and let them summarize maybe their 2 or 3 top tech issues and what's being done about it. So, one of the things, there's a lot that we could talk about, and obviously we don't have hours and days, but as we were preparing for this and in one of the prep calls, especially with Paul hasn't introduced himself yet, so you can raise your hand, but I was going through my list of questions and potential topics, and Paul said, yeah, that's a good list, John. You got about 3 days of material and multiple tracks there. So, but we're going to cover it very well in about 50 minutes. So they will also be available. So we probably won't do Q&A. We'll probably run out of time. But they are available afterwards for just like a small sort of group one-on-one conversation. So don't be shy about that as well. So I'll introduce this quickly, kind of explain what we're going to cover, and then let them introduce themselves. So here's sort of going to be a flavor of what we're going to cover. So one thing, blockchain is hard. So decentralization, very different than centralization. And because it's so different, it makes it hard. And we want to talk about that a little bit. And the technology, I mean, the dev tools actually kind of aren't very mature, and they kind of suck. So we want to talk about that. Decentralization, distributed ledger technology consumes more resources than centralized technology. It's more expensive. Is that an issue, or is that a feature? We'll talk about that. As a matter of fact, I think some of these issues are perceived as issues in the industry, but are they really issues, or is that just the way it works? We need to get our heads wrapped around that. There are public network versus private network issues, and even just the differences. But you get into the public space, you have privacy, energy consumption, proof of work versus proof of stake. Or can a good enough incentive system be defined to prevent the human nature to group together and overcome systems? For that matter, will public networks even be successful if digital currencies aren't successful? You get in the private network side, and you don't have digital currencies. So what is the incentive? Part of the solution in a private network is unavoidably centralized. So how centralized can it be before it becomes you shouldn't be using blockchain? And there's lots of works to establish a consortium or establish the network. And what it typically means is competitors are working together to do it. Then you can move on to smart contracts, and it's code. And code has bugs, and it's a large attack surface. So security becomes an issue from that perspective. The threat of quantum computing. And then another security-related issue is securing the network. Seems like a lot of that's been accomplished, but there are issues. But once you get past securing the network, then you start hearing about the transactions, the ordering of the transactions, or the speed or the scale issues. And then finally, if we get past that, we'll talk about some technology governance. And you got this decentralized thing. We're used to governing things, to moving things forward centrally. So you got multiple parties, and you got to govern the technology, and what are some of the issues there. So does that sound like the list that we thought we were going to talk about? Okay, so with that, I'll let the panelists each spend a couple of minutes introducing themselves and telling us a little bit about their company.
Okay, well, thank you. So I'm Mance Harmon. I'm one of the 2 co-founders of Hedera Hashgraph. Hashgraph as a technology is an alternative to blockchain. We'll probably touch on that a little bit. In terms of background, deep tech. Lehman Baird is the inventor of Hashgraph. He's a PhD from Carnegie Mellon in computer science. He and I have been working together for 25 years. We started off as young officers in the U.S. Air Force doing machine learning research. basic research for the Air Force Senior Scientist for Machine Intelligence. We both taught computer science at the Air Force Academy. I was a course director for cybersecurity there. Managed a massive software program for the Missile Defense Agency, basically a war game program to make it possible for our government to learn how to protect its citizens and allies. We decided we wanted to be entrepreneurs, and so we knew nothing and sort of dove headfirst off the cliff, and we've founded and sold 2 prior companies in the space of identity and access management. And in 2012, Lehman went to work on what today we call the Hashgraph. He had a major breakthrough in 2015. We decided to commercialize it, and here we are 3 years later preparing to roll out a public network based on that technology.
My name is Paul Snow. I didn't grow up in Texas. I grew up in a neighboring state to the east, Louisiana, 5 miles from the Texas line. I dropped out of my PhD program at A&M after having spent a year in Dallas working for Texas Instruments back at the dawn of time. It was hard to break those rocks in those days, but that's what we were doing. The short story is I wrote the first PostScript interpreter to ship in a commercial printer as a clone of PostScript with Adobe. So I was in the digital printing revolution. I came to Texas shortly thereafter, and I wrote the rules engine for Texas Tiers. Tiers does all the eligibility determination for Health and Human Services here in Texas. That system is also running in Michigan. It was the first rules engine-based eligibility determination system to be run by any of the states in the U.S., and it was written right in Austin, Texas, by a very small group of us. I got into Bitcoin fairly early, a lot of it by accident, just because I read a lot of Slashdot and tech forums and whatnot. Didn't pay a lot of attention to it, but I did at one point buy a bunch of Bitcoin at 75 cents. So you can imagine how heartbroken I am that it's only worth $6,000 and some today. That, unfortunately, I didn't buy enough, but I did buy some. I founded the Texas Bitcoin Conference, and I have been running a user group for blockchain and Bitcoin in Austin since 2013. We meet every Tuesday at 7 o'clock somewhere in Austin, and you can find us on meetup.com, and you can if you're ever in Austin, I just hope it doesn't explode. Anyway, so if you're in Austin on a Tuesday evening and want to come by and connect with the meetup, you can. So a big enthusiast for the blockchain, been thinking about it a long time. In 2014, a investor threw money at me and said, "You've got to build something that is actually usable by enterprise, just a problem." I dug through the problem. I spent a couple of months, I dug through essentially your list, and we came up with Factom, and Factom is, at least in our assertion, the solution to a lot of the problems that blockchain has. Some of the problems, like you say, are not real, but some of them are. And that's where we are today, and I'm here to talk to you about how the blockchain can solve real-world problems.
Hi, my name is Kumar. I'm with IBM. So currently I'm the CTO for the Pepsico account. Been there for the last 6 months. Prior to that, I was the CTO on the Walmart account for 5 years, where most of my blockchain experience has been. So I'm not building any of these underlying technologies, the protocols, as these two gentlemen are doing, but I've actually used the blockchain in a production environment and to see a business case. So I can talk about challenges about what a developer feels, or how much should it scale, not scale. And you started out by saying, we're all pioneers. Maybe these guys are pioneers. I'm a fast follower, the way I look at it. So I look at technology which is interesting and see, what kind of value can I create out of it, whether it's a startup or a business. So.
You're a pioneer, Ben. Admit it. Okay, thanks, guys. So we're going to start first with the easy one, and we've sort of alluded to this, and it's a fun one too. But so during this conversation, do we call this thing blockchain, distributed ledger technology, DLT, or something else? Is there a consensus?
Well, it's not blockchain. To be clear, blockchain as a term refers to two things. It refers to a data structure, a linked list of blocks of transactions, and a consensus algorithm that the community uses for taking new blocks and deciding which blocks go on top of that list. And there are a wide range of alternative consensus algorithms and data structures. Blockchain, of course, is the one that's most popular or most understood because of its association with Bitcoin. But as somebody said, blockchain as a term is going through its hype cycle now. I think there will be others that go through their own hype cycle. But blockchain, in my opinion, is too narrow of a term. Having said that, Ethernet, back in the day, you probably remember, Ethernet started off with a certain protocol and then went through lots of variations in terms of protocols, but the term Ethernet stuck. And so who knows what's actually going to happen in the market, but from a technical perspective, I would vote against blockchain.
Opinions? Consensus? We got three people. We can get consensus.
Well, I would assert that my friend here would like directed acyclic graphs, perhaps.
Hashgraph.
Or Hashgraph. But you're not a directed acyclic graph?
We are.
Okay, there you go. And so directed acyclic graphs, blockchains, and even some of the consensus architecture behind Hedera of R3. All of these are distributed ledgers, but they're not necessarily the same data structures. So I will agree with my friend, but I also would assert that for most of the community, they'll hear blockchain technology, and most of the people that aren't literally blockchain technologies will be happy to market into that space. So let's just agree that we care, but we don't care that much. I'm useful. I'm happy with all the terms, distributed ledger.
What do you call it?
I tend to call it blockchain because I can make a claim for a blockchain architecture, and I like to edge out these directed acyclic graph people. But that's just me.
I look at it as where the investors are putting money in, right? If you're starting a new company right now, and you say if you're a DLT technology, you're not getting any money. If you say I'm a blockchain company, it doesn't matter if you're selling tea.
Yeah.
You say I'm running tea on blockchain, you're going to get funded.
Yeah.
So that's what is going to get market adoption. So
Okay,
the
so
terms really don't matter.
So we don't have consensus on that. So we'll just call it whatever we want. So let's start with the blockchain is hard. So as a technologist, I'm experienced, but it's my time spent in centralized systems. That's what I'm used to. That's how my brain works. And jumping into this space was hard because it is so different when you're working on decentralized technology and just the way you have to approach it, and even just the security models and those kinds of things. So it's hard, I think, from that perspective. But what's your guys' and that becomes a technical issue. I guess it's sort of a personnel issue too. But what's your guys' perspective on that?
So we're going in a certain order.
Easy?
We don't have to.
We can.
I'll start with mine.
Okay. All right.
This man has experience actually trying to use it, so his opinion matters. But I'm going to get out in front of him and say that the real difference is two things. A blockchain or a distributed ledger is a shift from centralized systems of record, which we all understand, to decentralized systems of authority, which we don't really understand as much. And by distributed as systems of authority, I mean that since everybody has the ledger, then it becomes important who is the source of the data. If what's my authority behind this data? That becomes what's important. Today, and I'll go back to my DHS, my Department of Health and Human Services here in Texas. Today, when an interface goes down to Social Security Department for them, they can't process eligibility because they need to go against the system of record to know whether this person has these SSI benefits or not. And so if we move to a system of authority, they can have the signed record and maybe have a ledger where they look to see that no other record now yet exists. Therefore, they can use the data they have. So better efficiency, better communication, more sources of the actual data, as long as you can establish the authority of the data, and you get more efficiency. But that second layer, I have to convince everyone out there that programs to change how they think about the problem, and that makes it hard.
The way I would look at it is, depending on what role you're playing, right? If you're focused on building a DLT technology or a blockchain underlying protocols, yes, it's hard. Distributed computing is hard, right? People have been at it for the last 30, 40 years. So it's not an easy problem to solve. But then if I'm looking at it from what do I use it for, right? I'm creating an application, whether it's smart contract, whatever. It's still slightly harder than traditional programming, but it's much more easier. It's not any different than writing a program in C or Java to create any business application. Right? So at the end of the day, it's depending on what role you're trying to play. So when we did stuff at, say, Walmart, we're not building the underlying technology or the protocols. Those are already built by really smart people, like the gentleman here. They're providing APIs. And then you're writing code against the APIs using either Go or JavaScript, which everybody knows. There are some paradigms you still have to keep in mind because it's not going to one centralized database, but
so there's layers where people are a little bit ignorant,
right?
Or can be still. That's a good point. Anything to add, Mance?
Yeah, so just like 60 seconds on what this thing is and what makes it hard, right? From a technology perspective. Really, what we're talking about is a fancy new type of database. And if you look at the evolution of databases, you start with a single database, and maybe there's one or multiple users of that single database, but you want a backup of that database. And so you add another database over here. We've got a master database that's reading and writing information, and then a slave database that all that information gets copied to. So if the master goes down, you elevate the slave to a master, and you've got redundancy of your backup. But that wasn't good enough. And what we wanted to do as an industry is say, well, let's, instead of having a master and a slave, let's have two masters. And you want lots of people writing to one master and writing to the other master at the same time. Well, sometimes when you do that, you're writing to the same location in the database, and there's a conflict. And you have to come to agreement then between the two masters who wrote first in order to keep those databases in sync. The problem becomes compounded with every new master that you add. The more masters you have, the more often you have these write conflicts. So we've been doing distributed consensus for this kind of technology for a long time, as has already been mentioned. What's new here is the ability to do it at scale. Instead of having 3 or 4 or 5 masters, having dozens or hundreds of masters. And that another major difference is that traditionally all these masters were under the control of one company. Amazon running all of its masters, its multi-master database architecture, would never think of giving Google one of its masters to be the administrator of. That's a significant difference. That was the contribution of Bitcoin blockchain when it was introduced for the first time. You could securely take one of these masters and give it away to somebody that potentially is your competitor, and maybe even they're unknown to you. So this is the evolution. This is what we're talking about. We're talking about a massive multi-master database solution where the masters are owned by people that are potentially competitive and maybe even unknown. Technically, that was really hard to achieve. We're still evolving that. Bitcoin blockchain demonstrated for the first time it was technically possible to do it securely, and now the market is evolving to improve upon that.
That's good. So
let me add to that just a little bit, and this is a very short thing. It's something I'm very fond of saying lately, so if you've heard it before, oh well. North Korea was early this year was accused of mining $200 million of Bitcoin, and this was supposed to be very, very bad because they're a bad regime and they're supporting their regime with Bitcoin. Okay, but the point is, to your point, which of us wants to move our business into North Korea? None of us. But the math means that the only way North Korea can mine the Bitcoin is if they follow the rules dictated by cryptologists who are probably neckbeards living in their mother's basement. Seriously? Now, 2 months before that, a story came out that they are counterfeiting the new uncounterfeitable $100 bill. Okay? Now, the contrast is the $100 bill is backed by armies, treaties, agreements, probably the UN, all central banks. And all of that is supposed to prevent any actor, particularly a state actor, from breaking the rules. And yet the rules are broken. Bitcoin has no one that is enforcing its rules. There's no treaties, no agreements. The UN doesn't care, and the central banks would like it to die. And yet North Korea is following the rules. So this is what the distributed technology is doing. And what we're up here doing is saying, okay, if that works so well with tokens in Bitcoin, how can we use this for food safety with Walmart and for other applications?
Right.
And so I just wanted,
that's great.
It's that distributed architecture, and you don't have to trust the parties running it.
That's good. So you started alluding to the scale, so let's get into that. And so a way of introducing this is, assuming there's going to be billions or trillions of transactions in public networks, or even millions, billions in private networks. So we have a scale question there, but how do we do them quickly in terms of transactions per second? How do we ensure they're secure, unhackable, indelible? They're fair, they're ordered in a fair way, where order is important. And then when we have security, speed, and fair ordering, how do we scale it out globally, or even just in a private network to hundreds of nodes? So let's take those sort of one at a time, possibly. If that's, I don't know if this is going to be possible. But from a security perspective, so the network being unhackable, indelible, or the data are safe from attack, I think to some degree, obviously, that's been achieved to your point with Bitcoin. But from a security perspective, are there issues there still? And I think, is it only just a time perspective where we just need more time for it to prove itself and for people to become convinced? Or are there still technical issues, and maybe when you get into proof of work or proof of stake, there's still some technical things from securing the network perspective?
I think on the security side, even if you look at Bitcoin, right, the underlying protocol is, yes, it's secure, right? But then you also hear all this news about, hey, this particular exchange got hacked. And the reason for that is you're putting a centralized front-end to store your keys on top of a decentralized network. And that's what is getting hacked. But then the general perception in the community is, oh, Bitcoin is not secure because it's hacked. You feel the same thing even on a public or a private network when you go to talk to enterprises like a Walmart or a Pepsi, because executives are reading these news saying, oh, Bitcoin got hacked. So the underlying thing is, oh, blockchain is not safe, right? So there's a perception issue there that needs to be solved, right? So there's a security as a protocol layer, and then there's a security at, how do I now make sure that my keys are kept safe? Yep. And that's still a problem that's not easily solved, because, you have this massive 256 or something identity hash that each individual participant in the network has. But where the hell do I store it? I mean, how many people keep on changing their password, right? I mean, you keep a Post-it note or keep it on Notepad or somewhere else. And if we're running a Bitcoin node or a Hyperledger node or whatever, and if some participant on the node is keeping his identity or the hash written down somewhere, all rules are off.
Okay, good point.
You can talk.
So there are layers of issues here. When we think about Bitcoin, it's been around for 10 years. And, it's considered to be pretty secure. When we begin to think about the fact that we're so early in this, and that this market, as it matures, these public platforms anyway, are going to be processing probably trillions of dollars of value, right? The transfer of trillions of dollars of value. And when we contemplate that, what we want to do is start with the very best security that we can start with. In the field of distributed consensus, there is a gold standard that for decades was unachieved at scale. It's something called asynchronous BFT. It's not important to remember what that phrase is, asynchronous Byzantine fault tolerance. But what is important to understand is that it exists. There is a gold standard, and it's not been achievable until recently. Now, this is a sales pitch for Hashgraph, but one of the inventions, or one of the advancements that Hashgraph represents is achieving asynchronous BFT at scale, and it does so uniquely in the market today. Practically, what that means is that there are categories of attacks on the network that simply are impossible, that could potentially be levied against other non-asynchronous BFT technologies. Are they hypothetical? Well, sure, they are. But at the same time, as I've already mentioned, we will be processing trillions of dollars of value, and you have to assume that you're going to be attacked, right? The higher the value, the higher the reward for successful attack, the more likely it is bad actors are going to try to attack you in those ways. So I think that there has been room for significant improvement in terms of security, and security is not just securing the different layers of the protocol stack. Of course, you need to do all of that, and use best practices, etc. But security really has to start at the algorithm level fundamentally. And once you get that right, if you start with that building block, then the house that you build with the ABFT building blocks looks very different than what you can build otherwise.
Yeah, and so what Mance is saying, and maybe talking around, is Hashgraph has this mechanism for collecting data at scale in a attack tolerant way, sort of thing. And Factom is building a similar type architecture with a slightly different architecture at the very bottom. In our world, we thought, how do I make the blockchain look like your video screen? Your video screen is driven by a graphics processor that has thousands of processors on it, so that you get, in your video games, nearly real life video produced in real time by all these processors. But that's because the problem can be broken up into pieces. And in the blockchain world, we call that sharding. They built a system that can be sharded. We built a system that can be sharded. Our friends at IBM and Walmart are using a technology where they can create a blockchain for a application, and you can run several of them in parallel. So they can shard their problem. And so in the end, the scalability problem for enterprise can be addressed with the blockchain and with BFTs.
When you say enterprise, are you mean specifically private networks?
Yeah, actually, no, not necessarily private networks. It's basically for businesses that want to solve real-world problems like supply chain problems, or audit trails for accounting and business, or for loan origination or insurance processing. All these various parties, they all have enterprise problems they would like to solve with the blockchain. And we all represent ways of solving those, and solving those scalable problems, and solving those security problems. So I think we can summarize this without going into a lot of the details, that there are answers, and blockchain will change the way a lot of these businesses and these sectors do business.
Yep. And so probably the takeaway there is, well, I guess we've sort of bled into the scalability part too.
Right.
It's what we hear most about, obviously, is Bitcoin and Ethereum's scale problems, and tied to, I guess, proof of work. But we hear also a little bit about private network scale problems, not nearly as much because private networks are private. But the takeaway is this is not something that there already are solutions, and I don't know how. I mean, I know the Hedera stuff is close to being in the wild, and from Factom's perspective, I'm not sure where your scale things are releasing. But from a private network perspective, I mean, I don't know, Ben, if you can talk a little bit about, shed some light on, okay, in these private networks, what is being achieved from a scale? Is this just being blown away right now in terms of the solutions that Hyperledger is coming up with, or other people are contributing to, or IBM is coming up with, and that 6 months from now, it just is not really discussed that much? Or
I mean, scale is definitely an issue, right? I mean, there are two ways of looking at scale. Scale is, one is number of people who can participate, number of nodes.
Yeah.
Bitcoin and Ethereum have achieved that. I mean, anybody can spin up a node and start participating in it. But how fast do those transactions happen, right?
Yep.
Okay, the Bitcoin you're talking about, several minutes. Ethereum, same issue. And the transaction throughputs are the next piece of it. In Bitcoin, we get about 7 transactions per second. Ethereum, about 15. So if I look at it from a public network, if I'm transferring something as simple as money across countries, I'm willing to wait for 2 days, because right now my other choice is a bank, which takes 5 days to transfer the money.
Yep.
So 2 days is a lot faster than 5 days. So I'm willing to live with that. So that's technically, it scales. But then if I'm looking at it from an enterprise perspective, if I'm doing transactions and my supplier is supposed to send me orders, then the scale, I can't wait for 2 days before the order shows up. It needs to happen within seconds or minutes. Or if they're doing EDI now, EDI takes an hour. From an hour, if it gets down to minutes, they're still okay with it because it's better than EDI. So that's kind of how they are looking at it. And there will be people who are working on the scale issue. With Hyperledger, I know we got some internal benchmark. They've gone up to 4,000 transactions or 5,000 transactions per second. So those are coming. There'll be new technology, new ways of doing, consensus. Most common one everybody hears about is proof of work with Bitcoin and Ethereum, and which is time consuming. It takes a lot of horsepower, not a good way to create a scalable, decentralized network long term. So there will be other algorithms that are coming up, right?
Okay, so I hadn't heard of the EDI comparison in terms of something taking an hour and taking minutes on distributed ledger. That's sort of interesting. But so you're seeing also the 5 or several thousand transaction per second stuff around the corner with some of the private Hyperledger stuff.
We're doing 3,000 for TPS for now on the Hyperledger networks.
Okay, so I don't necessarily want to spend too much time on this, but I think it's interesting. It's an interesting topic, and it's always a question that people have too. But Ben, you kind of brought it up again in terms of the proof of work and even just the proof of stake, and just a little bit on, I kind of asked this question. Proof of work gets criticized a lot because of the energy consumption or even the slowness. But on the flip side, it offers like this ton in terms of providing security. I mean, it's this fortress of security. But then I also look at proof of stake, and it's like, well, okay, that hasn't burned in, and will that work? And actually, we kind of even. I guess we start bleeding into the incentive stuff here, so maybe we set aside the proof of stake thing first. But just your quick comment on proof of work and the criticism and different ways of looking at that and how that might evolve.
Well, I'm closest to proof of work. Okay, so here's I can explain proof of work and proof of stake, and the contrast is important. Proof of stake means that the parties that are involved in the moment all decide this is what data should be recorded and this is the order and so forth, and they record it, right? And you can think of proof of stake as us today deciding we're going to make certain decisions, and this table and this table and that table and that table and that table are all going to vote. And raise your hand if you think we could do something like that and everybody would trust the results. At least just in terms of this room. How many of you believe we could take a vote in this room? Yeah, I think most of us could. I mean, we're not the Democratic Party, so we could do it here. We can trust the vote. But 3 weeks from now, if you didn't see the vote at the time, would you trust it? Could you trust it for your business process? No, because the room, we would have gone through how many meetings in this room with different configurations of leadership, all potentially making votes on this topic. Knowing the state of the system is easy in the moment because we're all sitting around the table. It's really hard to prove the historical record because you would have to figure out who was in the room at the time to know if the vote is correct that you're looking at. So proof of stake doesn't prove the historical record well. It proves everything in the moment very well. Proof of work is exactly the opposite. If all of you had to do a whole lot of work on your vote, and we had to take, like you had to carve it out of rock or something, okay, it would take a lot of energy and a lot of time, and we would have to look at all these rocks. But the carved proof of rocks, all these rocks proving the decision, would be there for all time, and you could go to any collection of carved rocks and say, yes, that vote is correct, because I can see all these carved rocks, and it actually took people with knives and lots of time to scrape all the stone into these shapes. And so absolutely, and that's the way proof of work works. It's math and it's electricity, but it's really, really hard work that I can look at and prove that somebody worked really, really hard to come to this conclusion. And furthermore, because of the way the blockchain works, every time you do a vote, it includes the minutes of the previous meeting, so to speak. And so it's that proof of work applies to the past, like Russian nesting dolls. And so all of the security that I create always secures not just what I'm deciding today, but everything in the past, okay? Proof of stake doesn't necessarily give us the same confidence about the past because we might have taken a wrong turn coming into the building and we just happen to be in the wrong room and we get a vote and we chase back their history and it's not even the right history. So I'm giving you the paranoia of everyone that wants absolute proof of the past. Proof of work is best. If you want real efficiency and ease of use, proof of stake is better because all of us can come to a decision really quick. And the future model will be a combination of both. The future model in Ethereum is proof of stake in the moment, proof of work for the past, just less of it. And you're seeing that in a bunch of other public technologies. And you get it through anchoring. So if you take your private chains and you anchor a summary hash into a public ledger, you can inherit the proof of work of Bitcoin. So think of it this way. If you could buy a safety deposit box that's going to be held in Fort Knox, do you feel like that'd be pretty secure? And what if it was really cheap? Well, that's where you'd put all your stuff, right? And so this is why we anchor into Bitcoin. It is the most secure proof of work data structure in the world today. And we anchor into it, effectively applying all of its security to our data. And I could explain anchoring and stuff to people later, but let's not go there yet.
Good. Anything to add to that one? Before one other piece of this is to talk a little bit about the ordering of transaction. It's a subtle, nuanced thing that doesn't get a lot of attention, but it's important for people to kind of understand. Once you get into it, you start seeing the issue of, hey, the order of these transactions is important, or can be. So I know you have some opinions on that. Mance?
So the ordering of transactions is all important. That's the point, right? If we have this multi-master database and we each are writing locally to our copy of the database, and sometimes we write to the same location, then we have to know the order. We have to agree. We have to agree on what the order is. If three of us in this room wrote to the same location, then we collectively have to agree on the order in which those transactions happen to the database so that all of our databases stay in sync. The question then is, how do you do that efficiently? And there's proof of work as a mechanism.
Well, but even in the proof of work in the Bitcoin sense, the order is not uncheatable.
So when we talk about fairness,
proof of work and proof of stake is arguing against potentially different versions of order. So I'm just going to throw that out. So the order is important in all consensus.
Yes.
Yeah, I got where you're going with it.
So another question related to order is whether or not any single party or small group of parties can influence the community on what the order is ultimately. Can they influence the community to adopt a certain order, right? I mean, the whole point of this distributed consensus thing is to remove the need to trust a single party and replace it with the need to trust that a community, at least the majority or 2/3 of the community are honest parties. And that's a better trust model. Now, I don't have to place all my trust in a single trusted third party. As long as not more than 1/3 of you are evil, then I'm okay. I prefer that, right? And so most of the time, that's the way these algorithms work. However, for the vast majority of the consensus algorithms in the market, it's still possible for a single party to have some influence over what the community ultimately decides is the order. And that's a problem. I mean, when you have a stock market, hypothetically, you have a stock market that's meant to be distributed, meaning there's no central market. There are a bunch of computers running a local copy of the market, and you want to trust that not more than 1/3 of those computers are bad or attempting to manipulate the order of transactions. If it's the case that I have bids and asks flowing into the market, and one party can prevent a bid from reaching the market or can change the order of 2 bids as they flow into the market, well, that's not fair. And so there's this notion of fairness, meaning that it should be impossible for an individual to have that much control or influence. In blockchain, the miners, the ones that publish these blocks of transactions, they completely dictate the order of the transactions within a block of transactions. Occasionally, I mean, if you have 1,000 miners, maybe one miner publishes a block 1/1000th of the time. But when they do, they're dictating the order of the transactions within their block, and they see the order of the transactions. They can create their own transactions and stick them in that block in any order that they choose. That's not fair. You wouldn't trust a market built on such an architecture. And it's not just markets. It's any time-limited business transactions. It's games. If we're playing a multiplayer game, you and I reach over to pick up a pot of gold at the same time. Who actually pushed the button on the keyboard first makes all the difference in the world. And so this fairness property is fundamentally important and doesn't exist in the first and second generation protocols.
Well, let's be fair about Bitcoin, though, because Bitcoin transactions are always spending unspent transactional outputs, and the party submitting the transaction is the only one that can sign the transaction to make it good. And there's not really a race condition between that transaction and any other set of unspent transactional outputs, which is why Bitcoin doesn't have a fairness problem, because as long as you're in the block for 99.999% of times for the one business use case Bitcoin's built for, cryptocurrency, right. It works just fine.
Yeah.
It's completely fair. What my friend Mance is doing is he's extending it to all the interests that most of you people out here are considering in your applications, because then fairness matters, potentially. So,
yeah, good clarification. Okay, so a little bit continuing with the speed and scale, and talking about the fact that blockchain distributed ledger technology is expensive, and then compared to traditional centralized solutions. So you have data, you have multiple nodes. The data is replicated on all the nodes. There's lots of compute. There's lots of memory. There's lots of disk space. You have a centralized system. You have, I'm exaggerating, 1 computer. Decentralized, 100. It's more expensive. What are your issue, feature, facts, and what would you add to it?
There's definitely duplication of data, right? No question about it. Every node has to keep a copy of it. But the reality, if you look at it, multiple parties in any transactions, they're all still now keeping their own copies of this. I mean, they're not directly the same copy. So if, say, there's a Walmart and there is maybe Tyson's who's sending chicken to Walmart, they all have their own ERP system. They all have their own system. Walmart ordered so much, I need to send so much. They have their own version of it. Walmart has their own version of it. So technically there are two copies, two set of storage space, two set of computers working on it. So now all you're doing is saying, okay, instead of doing that disjointed, let's just connect the two together. So as a transaction happens, the two parties are in sync, as real as it can be.
That's a good point.
Well,
So
particularly with the private ledger, where you're not expecting everyone in the world to have your data. But in a public blockchain, you could be talking about thousands of nodes that have the data, and thus you have a lot more replication. But this is all the difference between a hard drive or a rated set of drives. Okay, we all know that for efficiency and for disaster recovery and for fault tolerance, we need multiple copies of our data running in parallel. The distributed ledger technology is just taking that to one more level of paranoia. And there's always the data that's worth that kind of paranoia. Right. And with cryptography, you can put a very little bit of data in that distributed system to get all of the rewards applied to a set of data that's only kept in one or two places. So no, I don't think it's a problem. I don't think that is the huge. I think it's worth the cost. Let me put it that way.
Yeah, no, I agree. So when we think about AWS, Amazon Web Services, there's a price point for the use of those services. When we think about a public platform that's meant to sort of compete in concept with AWS, in the sense that you can build arbitrarily complex distributed applications, making API calls to this public infrastructure, analogous to AWS, the costs are going to be higher for storage. You wouldn't build necessarily a distributed YouTube where all of the videos are being stored in this distributed public ledger, right? You might build, or you might build a distributed YouTube where the payment layer is using this public ledger, but storing the YouTube videos in S3 is always going to be cheaper and probably the right answer, right? Why do you need to store the videos in the public ledger? You wouldn't. So I think that the use cases for a public ledger are going to be different than the use cases for an AWS, even though it's still the case that in some sense they are both general purpose programming platforms for building apps on top of.
So Mark, even in the AWS case, right, technically S3 is probably replicated across multiple availability zones.
So maybe I'm wrong. I mean, if it turns out that
different access, from somebody in China or India wants to access a YouTube video, he's probably hitting an S3 somewhere in Singapore versus here, right?
Yeah, yeah. But it's probably not the case that it's stored on thousands of nodes.
It's a matter of scale.
It's not in every node.
It's not every node.
Yeah.
Okay, so related to this topic, because and I agree, Ben, that there are cases where you have multiples, so you're just moving the multiples from one situation to now let's store multiples here. They were stored there, but there are situations where there aren't multiples and people want to distribute that and it becomes multiples. But a lot of people want to know, well, what are the use cases for blockchain? I'm going to flip that, and specifically for this case where it is more expensive because there is more infrastructure for certain scenarios. So what's your favorite example of when not to use it based on this issue? Do you have I guess you said the YouTube one, but do you have or the guidance on when not to use it?
If a central database works, then you should use it. And so this is the fundamental question. If you have a consortium of businesses and they are comfortable reading and writing to a database that's managed by maybe one of them or a third party, and there's no concern over security and trust, etc., then why use blockchain, right? So fundamentally, what this technology is used for are those situations where you don't necessarily trust the people that you're doing business with. I mean, you trust them on some level, right? You have a business relationship with them, but you don't trust that they won't manipulate the order of transactions coming into the central database, right? If you don't trust them in that way, then there's an application here. But if you don't care, then you might as well use a central database. It's far less expensive. It's far easier to use. That's sort of the characteristic of distributed consensus.
Anything to add?
So I would just say, I mean, when we talk to companies like Walmart or Pepsi or whoever, enterprises, right? The rule of thumb we use is if it's used within your company, there's absolutely no reason to use blockchain because you're all creating applications which you are just going to use it. But if you're dealing with third parties, whether your suppliers, your customers, and you're transferring data, whether it's a good example is EDI, right? People do a lot of business with EDI. It's been around for 30, 40 years. And so in those scenarios, blockchain would be a good replacement for EDI. I mean, even right now, some of the stuff we're doing with Food Trust is basically mimicking an EDI network, taking the same transactions, converting into a JSON, dropping it into blockchain. So you have both those networks running in parallel. The only thing the Food Trust is doing is providing them much more faster visibility into where the supply chain stuff's are.
Okay. The blockchain is useful anytime you're trying to coordinate multiple parties, people outside of your company. Anytime you have to prove the validity of your processes to a third party after the fact, the blockchain can prove that your data hasn't been changed, that your data was collected at the point in time that the decision was made, and that this is the data that you used in your decision-making process, and this is the conclusion you came to. So that you are held accountable for what you knew at the time, not all knowledge possible. Establishing the timeline, I'm told very reliably by a single lawyer who I can't remember his name, 60% of all lawsuits are, the time spent is establishing the timeline. And so that's a statistic that this impeccable reference you can use confidently in your research papers. The point is timelines are important. So where the timeline is important, the blockchain can help you. The last thing the blockchain does is it's a messaging service. When you write to the blockchain, everyone else, private or public or acyclic graph, whatever your technology is, when you write to it, you're publishing that a change has been made. Even if it's just a hash, a fingerprint of some decision process or document or event, everyone knows at least that there is a event that they need to go look at or research. And so messaging, responsibility, and coordination between parties. If these are your problems, any one of these or multiple parts of them, then the blockchain is a potential solution for your use case.
So Paul, I would just be very careful about using messaging because that's exactly the first thing that some of the execs, when we first started having discussions about blockchain with Walmart, right? We were doing blockchain 101 and they had a specific use case they were looking at. And the first thing those guys were saying, why don't we just use WhatsApp to talk to our suppliers?
Yes.
Why do I need blockchain and all this complicated technology?
Right.
I can do it with WhatsApp.
Right.
But then the other pieces of it is missing, right? The provenance and the guarantee that there's a timeline and nobody can hack the message and the response. Yeah,
the responsibility. Because if you have said that this event has occurred and you're on a blockchain, you will be held responsible for it. Right. If they got a random message through some communication channel, that was forwarded through an SMS into email, who knows, right? And so you need yes, point taken.
Okay, we are almost out of time. And I did say at the beginning that you could have a little bit of time at the end if you had some final thoughts on tech issues. But literally, we have like 30 seconds each if you want
30 seconds.
Any final parting wisdom on your biggest tech issues or...
So I think it's important to remember what the big picture is here, right? What is the big picture? And that is a world in which we can work together and play together and exchange goods and services together in a cyberspace where we're not trusting a third party to not do bad things with our data or with our privacy. That's the goal. What we've started with is the equivalent of a calculator. And there are only so many applications you can build on top of a calculator, 5 transactions per second. When we move to hundreds of thousands of transactions per second, that's a computer. And the range of applications that you can address with a computer is very different than what you can address with a calculator. That's where we're going. You know, the surveillance capitalism that we live with today in Facebook, where you are the product, not the customer, that can be addressed with this kind of technology. Fundamentally new business models will emerge from this. And we're still very early, but we're moving very quickly. And it will be faster than the transitions we've seen in the 70s with the PCs and in the 90s with the web. This is going to happen very quickly.
I think that honesty is a good thing. I think what the blockchain provides is a mechanism by which when people interact, and people, companies, businesses, organizations, even systems interact with other systems, they can create an audit trail for which they will be held responsible. And as we move to a world where responsibility matters, we can talk about real change. So my involvement in this space is very, very idealistic. I believe when I look at the history books and I see that we tried through revolution to change the world by having better governments, that didn't really necessarily bring the rewards that we wanted. You only have to read about the French Revolution to contemplate that. We went to reform and we created lots of regulations, and that didn't bring nirvana, or at least nirvana is not scheduled in this administration. The thing is, if we can get to the place where math works, the whole point of my earlier comment about North Korea, math is more powerful than armies. And if we can apply math to our business processes and our governmental processes, we can fundamentally change the world. And so me and a lot of people that I talk to, we're very idealistic people. We're talking about fundamental change. A lot of people will make money. There are a lot of business models for this. But the good news is they're going to be really, really wonderful business models. It gives me a lot of hope. Technology sometimes feels very dangerous. And I think the cryptocurrency is and the blockchain and the distributed ledgers are a technology of hope.
Okay. So you hit on math, so I agree. So instead of trusting people, you can always trust math. So that's one aspect of it. Other thing is the fact that you have a system where you have a chain of records which is immutable, so nobody can change. So I can always go back and see who created this transaction and the history of it, which is the provenance aspect of it. So those are the two key takeaways from, say, blockchain or any DLT technology you're using. The question goes back to how do I create value of this, right? It's no different than when the internet first started. Nobody knew about TCP/IP, and the internet came up. What else can we really do with it? So the value is going to come up when you come up with different business models. How do I do it? And is it better than how you do it traditionally now? In fact, there was a guy who came up with a study of an Airbnb transaction. If I replicate it on an Ethereum transaction in an Ethereum network, it'll cost him $30,000 to do one Airbnb reservation because of the gas cost. So that's not really a scalable problem from a business perspective. So the question is, if you're creating a business using blockchain, what is going to be your value? How do I monetize it? And how do customers pay for it? If you solve the problem, then this is a great technology to use.
Yeah, that'll cost 30 cents on Hashgraph.
It'll cost a penny on Factom.
Okay. So I knew you guys would be
on the blockchain.
I could sit here for hours or days. I don't know if the rest of the crowd could, but I certainly could. So and I knew you guys would be entertaining and very informative. So thank you for that. And let's give them some applause and some appreciation.